All right. You should have your notes in front of you titled Tides on one side, then the other side is Hydrosphere Review, and then your second sheet is Watershed. We're going to be going over these as we go together. So give me just 1 second here. All right, it is going to be student-led, so I am going to be asking for volunteers to step up. It is going to be student-led, so I'm going to be asking for volunteers. All right, so looking at tides, first of all, raise your hand and tell me, why do you think we've been discussing tides?
Because it has something to do with the moon.
It has something to do with the moon. And why did we choose to discuss it right now? It has to do with the moon. What's the other reason, Tim?
It's a lot of, I won't say natural disasters, but hurricane, storms.
Why did we transition to talk about tides right after talking about the moon and right when we're talking about the hydrosphere? Why did I put that right in the middle? Huh? The way our water is, because it's tides. Tides have to do with water, which is the hydrosphere. We just finished talking about the solar system ending with the moon, and the moon is a great direct effect on the hydrosphere. What on the tides? What else controls the hydrosphere? The sun. So do you see currently how astronomy currently is linking into hydrology? Okay, so very good. So looking at your note sheet then, it says tides are controlled by what? Moon. What from the moon though? The gravitational pull of the moon. Make sure you have that. A better scientific explanation of it would also not only be just the gravitational pull of the moon, but also the rotation of the moon and Earth. Because we know that the moon rotates how?
Clockwise.
But where though?
Around
the Earth, and the Earth rotates around the sun. Got that? All right. So then I need a volunteer to come up and draw. How many examples did you get for springtide? You should have gotten 2. I need someone to come up here and draw me an example for a springtide. And you can use the colors: blue for the Earth, use the green for the sun, and brown or black or orange for the sun, brown or black, however you want to do it. Make it look pretty. Give me the first example. But when you draw your example, Tim, do not give me an elementary example. Give me a high school example. So you should have some labels so that we better understand exactly what's going on in the springtime. All right? And be prepared to explain. Whatever one, black or brown, whatever one you choose. Make sure you label some things for us. That is that's his Earth. Okay, so Timothy, before you leave. Now we know that the Earth is made up of land and water. Tides have to do with
Water.
Water. Gravitational pull is going to be pulling on the
Water.
water. So, in Timothy's drawing, we have tides, meaning that so far, he says that the gravitational pull is coming this way. So that means the water is going to bulge out from the earth this way. So if you live on this side of the earth, you're going to be at high tide or low tide? High tide, because the water is bulging out. What exactly is a tide? Water that comes up on land. So say for instance, if my house is here and the beach is here, if it's high tide, where's the water going to be? It's going to be closer to my house. If it's low tide, where's the water going to be? Further away. Probably not even at the coast where it normally would be. Here, where the water would come here, it may go further out. Regular tide will probably be wished around here. But if I live on a beach or I live in an area where I live on a coastal land, then I want to be very careful in choosing my real estate or my property that I'm going to live at if I'm going to be living in a tidal area. Why? It could definitely flood. Definitely. So we want to be careful of that. So far, Timothy's picture is correct here because the water is going to budge out here. But Timothy says that the gravitational pull is a push, not a pull. So therefore, he's telling me that water is going to bulge out even more. Is that correct?
No.
No, Timothy. Why? What's going on?
Moon gets the earth gets the pull.
Okay, so you don't need to rewrite it. So therefore, it's not the earth pulling on the moon, it's the moon pulling on the water from the earth. So therefore, our water would bulge out like so. So again, if we're on this side of the earth and on this side of the earth, we're having extremely high tides. If we live in the North Pole and the South Pole, then we're having what kind of tides? Low tides. All right? So, thank you, Tim. Let's give him a round of applause. Let me have someone come up and give me an example of the second type of spring tide. This one involves a full moon. The next one is going to involve a new moon. Come on now, Jay. Keep his up here and draw yours right underneath, okay?
This still for the springtime?
This is still for the spring tide. Make sure you label things. You don't know what goes on right now. While Isaiah is drawing, let me do some review here. If we were on this side of the earth, keep drawing, Isaiah, this side of the earth, and it was nighttime, what would we see outside?
What?
Would we see the moon?
No, because the sun right here.
We wouldn't see the moon because what type of moon is it? A new moon. And new moon signifies that we don't actually see it because of, remember where we were in our shadow, we were lined up like so, so therefore there's no reflection of the sun on the moon, therefore we do not see the moon. Should there be an arrow in there? Thank you, that's what they say up here. So, what Najee is saying, what Najee is saying here then, here we have our earth, here we have our moon and our sun. Remember, tides are from the gravitational pull from the moon. So he's saying that water is bulging out from the earth on this side. So if you live on, what is this? What is this? What coast? East, because we have never east. You walk into never east, never east. So this is the east. If you're on the east coast, or in the eastern hemisphere, I should say, not east coast, an eastern hemisphere, then what kind of tide are you experiencing? High tides, higher than usual. Here, and here, you're not experiencing any high tides there because of where the moon is positioned in relation to the sun with the earth. So it's pulling this way. So Najee would be definitely correct in this being a spring tide. Notice, what is the similarity between the two pictures for a spring tide? Michaela? Nope. It always does. They're all aligned. One is the moon is on this side, but it's all in a straight line. The other, the moon is in the middle, but it's all a straight line. Any questions about this? All right, thank you. Let's give Najee a hand.
I think the new moon on the left, that's all.
Yes, because it couldn't be over here, because then it would be a full moon. Yeah, good question. She said she drew the moon on the left. Is that incorrect? Yeah, because the new moon, remember, you can't see the reflection of the moon, because remember, we're doing it in relation to the earth. New moon means there's no reflection of the sun. All right, so in our explanation of springtide, what did you write for what a springtide is, Michaela? Okay, only occurs during the new moon and the full moon. Very good. What else could we put there? What else did you write? Earth to the people in this classroom. Madison.
Higher high tides and lower low tides.
Higher high tides and lower low tides. These are lower than usual. These are higher than usual. This is where we should be worried. That's why when you have real estate on the coast, they're very conscientious and concerned about when the moon phases are. Remember in your lesson when you did your test and you looked and saw when you were born, what was the moon phase, and you were able to see that after how many days does it take for the moon to get back to its same phase?
365 days, 6 hours.
No, I'm sorry. That's how long it takes the Earth to rotate around the sun. But, way to good thinking. How long does it take, if the moon is at a full moon, how long will it take for it to be a full moon again? Approximately a month, 26 to 29 days. So therefore, people who live in the Western Hemisphere and the Eastern Hemisphere, they are concerned when their full moon comes. They know that every 29 days, there's going to be a concern about how high the tides are going to be. Why? Because of the full moon, the gravitational pull. People who live on the Western Hemisphere, the Eastern Hemisphere, not only do they have to be concerned about a full moon, they also must be concerned about a new moon. If people are fishermen, or people who, this takes you back to 8th grade, let's think about this. People who fish for crabs and lobster and clams and things of those nature, what zone are those located in? Intertidal zone, which would mean that they're further away in the ocean or closer to the coast? Closer to the coast. So, during the full moon and the new moon, what about the people in the northern, southern, and western hemisphere? It's going to be extremely low. So that means that it could be a possibility that those things are going to, those organisms are going to wash up on shore because it's low, so it may be really good that they can catch those things. Those organisms could be concerned about that time because that's where the birds are going to start coming in and eating them because their water has moved, their real estate has moved out of the way, so therefore they don't have that water area. And same thing when we get here and here. Questions about that? All right, what else can we write? We have higher than high tides, lower than low tides. What else? Greater tidal range. And in your test, you wrote what a tidal range was. And we already noted the fact that they're in a line with one another. And this is our spring. No, sorry, let me take it. Any questions? All right, then let's get ready to take a look at our neap tides. All right, let me have a volunteer then to come up and draw our neap tide. And if you already did it. Somebody else? Ready to pull a number? And volunteer. Hey, come on, Sean. This would be a good opportunity. I know you didn't have to. I volunteered you. You can put the paper on that board. Now get your reference. Make sure you label everything. Yeah. What is that up there? What is that up there with that circle? Label everything. What are the only three things that we're discussing? What are the only? Okay, so if you're labeling that the earth, then obviously you must think that must be the. So let me stop you for a second. Put your hands down. The earth rotates around the sun, correct? How can the earth rotate around the sun if it's not even in line with it? The moon rotates around the earth. If you do that, but the earth can never rotate around the sun being located there. You tell me. This is part of showing your true understanding of what you're doing. Because you would have to think about that, like, could this possibly be the earth? If it rotates around the sun, it couldn't be. Imagine, I want you to be quiet. Please, and thank you. Shut up. All right, so it is gravitational pull, so we'll fix that. No problem. All right, so according to Yushana's picture, here we have the moon gravity pulling on the earth, but also it's in line with the sun, the Earth's rotation around the sun. So what happens to that gravitational force that's being pulled this way? Keelan? They cancel each other out. Therefore, our water bulging would look like how?
Wait, I
Low
know.
tide.
It would be low tides. So our water bulging, it's still walled out some, but it's a very, very low tide. Everywhere is gonna have the low tide. Any questions about this? Let's give Shauna a round of applause. Let's give her a round of applause. I'm sorry. What type of moon should this be? It should be a quarter moon. Thank you. Bring that up. So it means this is the part that we see. All right, so in addition to the fact that it happens during a quarter moon, what type of angle does this happen at? It's no longer a straight line. It is now a 90 degree, which is also known as a right angle. It's when the Earth, the Moon, and the Sun are aligned at a right angle, obviously with the Earth being in that corner part. And again, like I mentioned to Yashana, the Earth could not go here because the Earth rotates around the Sun. It doesn't rotate like that. It has to rotate around the Sun, and the Moon has to rotate around the Earth. So we have to make sure they're aligned correctly. What else could we write about our neap tide? What else did you get? Feeling?
That's a small
Smaller tidal range. Correct. Good. Lower high tides. That can be confusing because it's lower high. So that means your high tides are not as high as they are when it's a full moon and a new moon. So people who have real estate in that area, they don't have to be worried about the high tides during that time. They know the high tide is just going to be something that's going to wash up all over the beach a little further, but it's not going to flood their homes. And then Tara also said higher low tides. In the times when the tides would be so far back where the organisms in the intertidal zone, like Tabarsi told us, would be concerned, they don't have to really be that concerned because it's not going to wash back too far. And we do see that the gravitational pull of the moon is counteracted or canceled out by the sun. Any questions about that? When you're finished writing that, go ahead and flip the papers over to the hydrosphere review.